Okay, so this is the one that we left off in class, finding the slope of those 2 points. Most of you had 0 over 5, which is equal to 0. And then you graphed it, and you should have seen your line come out like that. So the slope of the line in example 2 is 0, and the slope of any horizontal line is 0 every single time. So if I'm walking or running or trying to run, I'm always going to want to have a 0 slope because it makes it easier for me. So I want flat land. Horizontal, 0 slope. Okay, so for the next one, what I would like for you to do is do your labeling x, y, x, y. First pair gets the 1s, second pair gets the 2s, and then plug directly into your slope formula, which is y sub 2 minus y sub 1 equals x sub 2 minus x sub, meaning subscript 1. Go ahead and press pause if you'd like to, and then I'll show you my work so that you can check yours with mine. So I get negative 1 over 4. This is my work. This is actually my line for my fraction bar. And this is what my graph looks like. So completing our sentence, the slope of the line in example 3 is negative. It's a negative number, so it's negative. Which means the line falls from left to right. Negative. Falls from left to right. Don't use the coordinates there. Just say from left to right, because that's how we're going to be reading these. Then I like to do the same thing again using the same formula. And so I'm always going to label xy. First pair gets the 1s, xy. Second pair gets the 2s. And so your slope will be 1 minus 4 over 2 minus 2, which would be negative 3 over 0. 0, whenever you have 0 in the denominator, it does not equal negative 3 and it does not equal 0. It's always going to be undefined for those. Undefined. So slope of this one is undefined. And if you plot those 2 points, and then you connect your dots using a ruler, you'll see that that's a vertical line. And so to complete our sentence, the slope of any vertical line is undefined. It's so steep you can't even define it. That's how steep that line is. So as you look at these next ones, and I believe it's a little bit darker on yours, these are the lines we're looking at. And here's this one. We're going to look for 2 good points. So good points are ones that are right on the lines, not like halfway, not somewhat, but exactly there. So here's one of mine, and here's another good point. And remembering that slope is going to be your rise over your run. So if I'm giving directions from this point to this point, I'm going to go first up 1. And because I went up, it's going to be positive. And then I'm going to run 2. And because I went to the right, that's positive as well. So my slope is 1/2. Then it also asked me to classify the slope. So I'm looking at it from left to right, and it's going up, so it's positive. Looking at number 2, which is down here, I can already tell it's negative. It's going to be a negative slope because it's going down from left to right. So I'm going to go ahead and classify now. And then I'm going to pick my 2 points. This looks like a good point to me, and this looks good to me. So directions from here to here. I'm going to go down 1, 2, 3. So that's negative 3 because I went down. And then going from left to right, I'm going to go over 1. So this slope is negative 3. Just as a side note for you all, just so you can see this because not everybody believes me. But one thing I also want to point out is it doesn't matter which 2 points you choose, nor which direction. So let's say I wanted to go from here to this point instead. And instead of starting here, let's say I wanted to start, well, instead of starting from here, I'm going to go here. So I'm going to go here, I'm going to go up 1, 2, 3, so that's 3. And then I'm going to go left 1, so that's negative 1. I still get negative 3. And it works out pretty much every single time. So number 3, I'm flatlining here. This is what I like to run on when I run. And so there's 0 slope here. There's no slant at all. So the slope for this one is 0. What's my classification? It's a horizontal line. Now this one is your vertical line. We can tell that by looking at it because it goes up and down. And the slope of any vertical line, if you look back to what we had done earlier here, the slope of any vertical line is undefined. So this one is also undefined. That's how steep it is. All right, finally, I'm going to talk to you about rate of change. And for the first one here, you have the rate of change compares two different quantities that are changing. So, for example, speed is known as distance instead of. It should be over time. So as a fraction, it would be distance over time. So, example 1, you were hiking in the mountains. At 11 a.m., you were at 5,234 feet above sea level. And then at 2 p.m., you were 4,138 feet above sea level. So you're going down, it looks like. Find your average rate of change. So we know that it's going to be distance over time. So what's my distance? How far am I going? Well, if I started at 5,234 feet and I ended up at 4,138 feet, to find out how far I went, I'm just going to subtract those two quantities. And then the time that I started was 11 a.m. and I ended at 2 p.m. So 11, 12, 1, 2. That's 3 hours right there. 3 hours. And this on top is in feet. So when I subtract these two numbers, we get 1,096 feet on top over your 3 hours. And when I divide those two numbers, I get 365.333333, so 0.3 feet per hour. And that would be your change. Because you went down, though, I might make that negative because you're decreasing your elevation over time. So make it negative because you went down by that much time. Okay, so finally, you are traveling by car and you leave home at 8 a.m. By 8:45, you're 13 miles from home. You did some traveling there. Find the average rate of change in miles per hour. So miles per hour. Well, how many miles did you go? Nice of them to tell us. We went 13 miles. So that's going to be how far I went. And then how long did it take you? Well, 45 minutes looks like, because if I started at 8 and I stopped at 8:45, this is 45 minutes. But Houston, we have a problem. This is asking me for miles per hour, not minutes. Luckily for us, we have studied this before, and we know that 45 minutes over 1, we can use a conversion that there are 60 minutes in an hour. So 60 minutes goes on the bottom and 1 hour goes on top. Your minutes cancel out, and then you have 45 over 60 hours. I would use my handy dandy calculator and find out that that is 0.75 hours. Actually, I wouldn't because I know that by heart. 13 miles over 0.75 hours. And then when you divide that out, you'll get 17.3 miles per hour. And that is that. Thank you so much. I hope that you have a wonderful day, and I'll see you in class. Don't forget to study for your test, or your quiz, actually, your quiz. See you then.